My name is Vishal. I am founder and CTO of InfraCloud Technologies. I run the Kubernetes Pune meetup, so if you're around Pune, please do join us. Recently also started Rust Pune group to see the level of interest and enthusiasm and do something around Rust, hopefully in next few years. You'll find me in usual places, Twitter, LinkedIn, whatever. As I said, I'm from Pune. I love books, mountains, good movies. I have two daughters. One is an 8-year and 2-year-old, and my daughter loves stickers on laptop as much as I do. Cool. So let me first set the context of what we are going to talk about today, right? Uh, Basically, lessons from adopting and contributing to cloud-native technologies, for enterprises and for community. And this is working with various organizations of various sizes and kinds, across the world broadly. And a lot of it is about scale, cost, what kind of teams succeed and what kind of teams struggle to succeed when adopting innovative technologies like Kubernetes, Prometheus, and things like that. And the reason why we want to talk about this, I believe, is because this is only one of the first waves of technology innovations and disruptions we are seeing, and we'll see a lot more of these over the next decade or two. And the patterns sometimes are very similar when you adopt innovative technology like Kubernetes or cloud native in general. And challenges around team structure, scale, and cost actually end up helping or not helping adopt the cloud native tech right way or wrong way. And that is something which is going to remain kind of consistent across other technology spectrums that we will see. And obviously, we want to solve for the whole, which is the organization, and not just solve for one silo, which is tech. Definitely a good disruptor, but you still need to solve for the larger org, basically. I think this is just working here. Cool. So let me start with the first one. This is more of a personal anecdote than a lesson. So around 2012, 13, 14, I was working with Puppet, SaltStack, Chef, and provisioning infrastructure, doing stuff on top of that, right? There is no real reconciliation loop like we have in Kubernetes, and you would typically run these playbooks or runbooks every 30 minutes, 20 minutes, whatever made sense for your organization. While this was happening, Docker came along and became super popular in a very short time. And then Mesos also was, being talked about a lot. And I was working on Mesos. We had deployed Hadoop, we had deployed Kafka, we had deployed a lot of other things at scale across 7,000 machines for an ad tech company, all beautifully working like a charm. And obviously, I had heard about Kubernetes and played around with it a bit, but I never thought, anything but Mesos can win the orchestration race. And obviously, how wrong I was, we know obviously today in 2023. So Kubernetes is definitely the most adopted orchestrator among other orchestrators, and Mesos, more or less is now a relic of history. Now, why did this happen? So is it community? Is it open source? Is it something else? And I think, interestingly, there was a discussion on Hacker News just last month, I believe, where some of the committers from Mesos project talked about why they thought Mesos wasn't the right tool or why it didn't take off as much as Kubernetes did. My personal hypothesis on this, and my first lesson in my career in general in this space has been, definitely community is one of the big parts of why Kubernetes became the de facto standard. But what does even community mean? So one factor we probably discount a lot beyond people and code and community is the innovation. You're disrupting fundamentally something that was not in place, and you're bringing something of a new paradigm to the table, right? And that innovation is only possible with so many shared contributions from companies and people, who may not be seen or who may not be visible to us, as faces. And obviously, there is a shared interest and vision in that we can't deny. Everybody wants something out of the effort, the time, the energy they put in. And to me, that is what made Kubernetes as successful as it did, and proved my hypothesis wrong that Mesos is going to be the default, orchestrator. Let's talk about another story. Around 2015-16, I was working for a UK-based retail company. They had a simple web app, 2 backend microservices, 1 front end, managed database, all working great in AWS on Elastic Beanstalk and stuff like that, right? And features were getting delivered, things were moving pretty fast, and one of the engineers said, let's implement Kubernetes. Now, just to give you a context, in 2015-16, there was no managed Kubernetes except for GK, which was just launched 3 months ago. And you had to self-manage Kubernetes if you ever wanted to, with kops or similar tools, basically. So now we are talking about 2 worker nodes for the application, and 3 master nodes for Kubernetes. And I kind of pushed back on the idea a little bit, and I thought this didn't make sense from architecture, from organization point of view, from a cost point of view as well, and it wasn't taken very positively. But that was not the first time I had pushed back on an idea, because I remember similar time frame, MongoDB was very popular, and one of the interviews that I appeared for, the interviewer was very much like MongoDB is the only database you will ever need, right? And I think this kind of fanboyism of technology is not great, because technology is absolutely great disruptor, but business value is equally crucial. And I think we as engineers sometimes forget that. We forget the fact that beyond technology, there are other things that do affect how technology is adopted. And if we are not mindful, we will not be able to implement these great technologies, across orgs and teams, basically. My third lesson was for working with an Industry 4.0 company. So this was a company which was building an insights and analytics platform for things like turbines and pumps. And the deployment had to occur obviously on cloud, but also on an offshore oil rig. Completely remote, no internet of whatever sorts, and you had to still run something like Kubernetes on a very constrained hardware, basically. So constraints where you want something consistent that runs across cloud and edge location, but you still want extremely, extremely low footprint and very power efficient operation for cluster and applications. Now, in 2017-18 again, there is not really an option for a low footprint Kubernetes. Only in 2019, we saw the rise of Kubernetes distribution called K3s, and LF Edge was born. And I think this was a good lesson for me, that sometimes the problems that you see or the challenges that you face are a very good leading indicator of innovation and where to put your energies on. Another story for a telecom CSP. They built a self-healing platform for managing incidents and things like that using functions as a primary unit of deployment. And we did development, all that stuff, and eventually it came to deploying these to the customers, which are basically telecom companies, in their data centers, the data centers of telecom companies, basically. The only one constraint was you had only one node available for deploying everything, including Kubernetes, the workload, and everything on top of that. And when I first heard this from the customer, this was my exact reaction. How the hell can we do this? I need 3 master nodes, I need 3 worker nodes, only then let's talk about everything else, right? And it took me a couple of years to realize this was a mental constraint that I was carrying, because OpenShift had a single node deployment around 2021, and they were working on similar problems for customers, right? And now they have something called as MacroShift, which is even more constrained, even smaller and lower footprint deployment. So technical perfection is definitely good, but solving real problems is actually better. Another story for a application platform around analytics for search analyst. Basically, you type a query in the front end, and it goes and spins off thousands of compute workers or functions in the back end. And this was not working beyond a scale. The scale that they required in production at peak hours was basically how do you serve something like 7,000 requests per second, right? And when we got in, we did an iteration and did analysis of a deployment, did some benchmarking, and to my surprise, a very unusual suspect came out to be the bottleneck. It was the load balancer provided by cloud provider. What we did then was in iteration 2, beyond obviously tuning the code and doing other things that you could do, use simple vanilla virtual machines, install a software-defined load balancer on those, put a static IP in front of those, and it worked beautifully. Was able to scale up to 7,000, 8,000 requests per second. And that was a lesson to me again, that learn the tech at the lower levels of abstraction. Learn how load balancers work, learn how VMs work, what does Linux do at the operating system level. It'll serve you really, really well, and you will really have a good grasp of what you are doing with your application, companies, organizations, whatever. Another train company, they had sensors running on tracks across the country, and they were ingesting huge amounts of data into the system and analyzing that data. Just to give you a sense of the scale, they were ingesting 20 billion events per day. Out of that, in the peak hours, which is daytime, 1 billion events were being ingested every hour. And they were basically running a small compute of 300 milliseconds, and were done, basically. So this was a very event-driven kind of platform, and the organization had a question to answer for themselves. will the cloud serverless platform be the right choice? Things like Lambda, Google Function, Azure Functions, whatever you want to, name them, right? We did some analysis, primarily from cost point of view, and then obviously some other angles. So the cloud provided managed serverless offering would cost them $1 million per month. And for the data, it might actually be fine, right? You never know. Can anybody guess the same deployment running on Kubernetes and OS's function platform, how much less or how much more will it be? Any guesses? Anybody wants to take a peek? $200K per month. That is a huge 80% lesser cost at that scale. So when we talk about, again, trends like serverless, there are spectrum at the edges, of deployments where things start breaking. Your assumptions start breaking. So don't assume anything. Because even the one-time effort and operating cost of this self-managed platform was far, far lower than the managed services, offered by the cloud provider. And again, we as engineers probably don't like to, talk about money, cost, and economics. But I think it does matter. It does matter to the org. It does matter to companies. It does matter to the world, basically, right? And more so in 2023, You know how things are out there. And everybody's talking about how can we get more out of less. And if you're interested in anything to do with finance or finance operations in general, do join FinOps Foundation. It's a sub-organization under Linux Foundation. Does a lot of these things across orgs, and a lot of momentum happening around how do we do better finances when it comes to infrastructure. Okay, another story, working for a finance company, very compliance-heavy legacy software built over the last 15 years, pure play Java. 3 objectives to be achieved, and we got involved: monolith to microservices, virtual machine to Kubernetes, and migrating to modern CI/CD. Now, one thing I would like to point out is, as a consultant, you have a very interesting vantage point. You're not emotionally involved in a way, but you're seeing things up close, and that gives you a very dispassionate view of things, right? What could have been better, what we could have done better, things like that. Now, this was an extremely complex organization, multiple silos, multiple organizations. For example, the engineering team wanted the developer productivity to be the topmost thing to be solved. The CloudOps team didn't care about developer productivity. All they wanted was there is no intrusion detection, or there is intrusion detection system for host and network, and security is the topmost thing, things like FedRAMP compliance and whatnot. And this was a very top-down initiative funded by CTO's office and driven like, hey, we need to adopt Kubernetes, and a big bang approach. And a lot of practitioners who were on the ground didn't really have inclination nor the knowledge of these technologies. So technically, change management at this scale is almost like a Pandora's box. You open something, and 10 other problems appear in front of you, and then suddenly what you thought you will do in a week suddenly takes 4 months, basically. 18 months down the lane, this program was stopped. Everything down the drain. The money, the effort, the energy. And this organization will never even try to do something like this again, because that fear of failure is far, far bigger than anything else. And if I would be the CTO of this kind of org, I think there were 2 layers of learnings I would have. The first thing is, do any transformation in a minimal, viable manner. Find out the shortest path that you can get to from something modern tech into your org, running in production. Don't try to do big bangs. And secondly, align progress over perfection. If you end up doing perfection as the goal, it'll probably take millennia to even do Kubernetes transformation, trust me on that. But now applying antithesis principle to these learnings, there is a second level of learning. In any org of this complexity, change is hard. Probably change is the hardest thing, more than even technology. So always have a champion team who is learning, who is willing to be part of open source, communities, what is happening outside, and make them, nurture them, and when the time comes, they'll be the people for you to go and actually make this change happen. Because expertise is available outside. There are people, there are companies, there are technologies, whatnot, but change is your internal problem, and absolutely nobody can, unfortunately, help with that. Okay, final one. We're working with a network org, and this was Prometheus, scaling and usability challenges. And we got involved, and we basically suggested them, implementing Thanos and Cortex, and this was the time, probably 2019 late, 2020 early, when both of these components were still evolving. They were kind of looking at what each other is doing, what designs are evolving, and there was talks going on around merging these 2 projects. So we basically were able to redesign the architecture, introduce Thanos, and make a few upstream PRs to make sure whatever features we needed in our org or for the customer were actually made upstream, right? And that worked beautifully well. The monitoring system was pretty stable now and was able to scrape a lot more than it would in the past version. But how many orgs really contribute to OSS? And how can we change that is the question I think we should be asking all ourselves. So my lesson and also call to action today, when you go back tomorrow to your offices, I would say do two things. And this is something really occurred to me when I was in the maintenance meetup day before yesterday, with Nikita and our own bunch of folks. We need to do two things. Make a business case to your org of supporting open source. If you're using open source, there's a risk of somebody not maintaining that project, that dependency, that library, and that running into security issues and whatnot. We all know what happened with Log4j. We all know what happened with a bunch of these kind of things, right? It can't happen with 2, 3, 4 people dedicating their life to a utility, to a library, to an open source project. It has to be initiative that we all own. And lastly, make a case to contribute to OSS internally, also from hiring and talent point of view. Some of the smartest engineers I know, I never looked at their resume. I only looked at their GitHub profile, and I was like, good, I want to work with this person, right? And I think if we all make that case to our orgs, to our managers, to our executives, to be involved in open source in some sort of fashion, we will have a far, far better future and far more, far stronger movement of open source in India and in general in the world, basically. That's all I want to talk about. And one thing I want to share is there is a school of Kubernetes that we have written by one of our engineers and a couple other contributing. If you want to learn anything around Kubernetes, programming Kubernetes against Golang, and related topics, there are like 6, 7 odd courses. Please feel free to use them and learn the technology. Thank you.